Let me just hit the. So we're gonna just do a quick review from last time was properties of matter. Just to remind you that I did post an online quiz. That's due anytime this week. All right, it's just 20 questions. So take your time on it. So just keep that in mind. All right. I think what I'm going to do on Monday next week, we're going to do a Kahoot review. I actually tried it with grade 10s. It actually was okay. So what we'll do on Monday is we'll do a Kahoot review on everything up to and including today's stuff. All right. So up to today's material. That'll be fun. We'll just to do something a little bit different. Okay. So what we're going to do today is we are going to review properties of matter. Sorry, that's what we're going to talk about, properties of matter. Before I do that, we are going to just do a quick review of classification of matter, okay? So last time we talked about matter, and we were able to break it up into categories, right? We were able to say we can break up matter into pure substances, and mixtures. And a pure substance is something that's, imagine you have a substance, we'll call it A, okay? And we look at A through a special microscope, and we can see that A is made up of only one type of particle, which I'm going to draw as a green dot. So all of the particles that make up A are little green dots. So that would mean it's a pure substance. Whereas a mixture, imagine we looked at substance B, and we looked at substance B, and we see different particles. We see maybe some black dots, maybe we see some green dots, maybe we see some purple dots. So a mixture is made up of two or more types of particles. That's the big difference between the two. So we also then broke down pure substances into two categories: elements and compounds. So remember, a compound is if you have one type of particle, if we were to zoom in on that particle, maybe that particle is made up of two types of atoms, like for example, water. So we have hydrogen and oxygen, two different types of atoms. So that would be a compound. But if it's made up of only one type of atom, like HH, so hydrogen is actually two hydrogen atoms stuck together, but it's only one type of atom, then that's an element, okay? Whereas mixtures, we said, are made up of more than one type of particle, like this example here. And we were able to break down mixtures into three categories: solutions, mechanical mixtures, which are, so I'm going to use the word mechanical mixture, which refers to colloids and suspensions. Okay, and if you remember, so a mechanical mixture is either a colloid or suspension, and these are things where if you could, if you pay attention, you look at them, you actually see two or more different things. And the term for that, if you remember, is heterogeneous. Whereas solutions, elements, and compounds, those things were all homogeneous. Which means when you look at them, they all look the same. It doesn't, like for example, we talked about, like if I have like a sheet of aluminum, it looks the same. It looks the same everywhere. Okay. Okay. So Okay. Anyways, that's a good review for last time. So what we're going to do now, talked about classification of matter. Today we're going to go over properties of matter. Okay. So that's what we're going to look at today. Okay. So can you girls see this screen? Okay. Very good. All right. So let's make this a little bit bigger. Okay. So, all right. So what we're going to do today is going to do a quick little overview of the properties of matter. So we just talked about the classification of matter. Now we're going to look at the properties of matter. All right. So this is just a way of describing matter, whether it's pure substances or mixtures. It's just a way to describe. And there's two. We can break them up into two categories. We can look at them as physical properties or chemical properties. Okay. So a physical property is a way to describe the matter without changing the particle. So for example, you could describe matter using color and smell. That's one way to describe it. Here are some other examples. We can talk about, for instance, its shape. Whether we can talk about we can talk about whether it's like a solid, a liquid, or a gas, and describe things like its shape and its volume. So for instance, a solid is something that has a fixed shape, which means that the shape really doesn't change unless you do something to it. Whereas liquids and gases would take the shape of their container. So for example, I have a picture of a balloon here. The gas would take the shape of, in this case, a sphere, right? If I have a glass of water, the liquid will take the shape of the glass. Whereas if I have a glass here and I put like a cube of sugar in it, the cube of sugar does not take the shape of the glass. It just takes its own shape because it's a solid. The other way to describe it is, like its volume. For example, a solid's volume doesn't change. So if I put a cube here, the cube doesn't change volume, but gases do. So gases are different because, if you have a balloon, you could squeeze the balloon. If you think like, for example, an airbag is meant to be squeezed. So when it deploys and you hit the airbag, you can squeeze it. And that's because gases have a property where you can actually easily change their volume. You can squeeze a gas, you can make it expand. Whereas solids and liquids, their volume is fixed. If you have like for example, a beaker full of water and I have a plunger, imagine a plunger here, and I try to push down on that plunger, it's not gonna be able to push because you can't really change the volume of a liquid. But if that was a gas, we could easily push that plunger down and change the volume of that gas. Another way to describe matter is, how hard it is. So for example, there is a list. I'll show you the list here. There's actually a hardness list. I looked it up. And it's rated from 1 being the softest to 10 being the hardest material. So diamond would be the hardest material on this list. Obviously, not everything is on this list, but that's just another way of describing matter, is how difficult it is to scratch or dent it. Another way to describe matter is if it's malleable. That means if you can hammer it into thin sheets, like aluminum foil. If aluminum foil, you buy a roll of aluminum foil, it is, it's malleable, so you can make it into sheets. So for example, I have an image of that. So here, for instance, you could see that there is like a thin piece of gold. Remember Rutherford's gold foil experiment. So metals have the ability to be hammered into thin sheets, so they are considered to be malleable. Whereas the term ductile is the ability to convert something into wires. You can stretch them out into wires. Think like, for example, this is copper wiring. Aluminum can also be stretched out. A lot of metals can be stretched out into wires. So that property is called ductility. Okay, if something is ductile, we can convert it into a wire. Again, all of these are ways of describing matter, but without changing the particle. So we're not doing anything to the particle by describing it. So if you take, for example, a piece of aluminum and you hammer it into a sheet, you do nothing to the particle. The particle stays the same. If I take copper wire and I stretch it, if I take copper and I stretch it into a wire, I don't change the particle, all right? Melting and boiling, same thing. If I have, for example, water, and I know water will at a certain pressure, like our regular pressure we're used to, standard pressure, water will boil at 100 degrees Celsius, and it will freeze at 0 degrees Celsius, right? But again, when you boil water or you freeze water, it doesn't change the particle. It just changes the state. So if you boil it, you convert it into a gas. And we said what a gas is. It's something that takes the shape of the container, something that you can easily change its volume. If you freeze it, it becomes a solid. So that means it'll have a fixed shape and its volume will not change. And if it's a liquid, that means in between 0 and 100 degrees, then we know it takes the shape of its container, but its volume is fixed also, like a solid. We can also describe matter in terms of its crystal form. So for example, if we were in class, we'd actually be doing this. This is actually quite nice to look at. You can see like certain crystal shapes on this slide, but I pulled out some examples here. So on the left, this is salt. And on the right, this is, I believe this is magnesium sulfate or Epsom salt, if I remember correctly. You can see the crystal shape of salt is kind of like almost like a cube, right? Whereas magnesium sulfate looks a little bit different. So that's another way of describing matter, is based on the crystal shape that it takes. Okay. We can talk about how well it dissolves. That's another way to describe matter. So for instance, salt. We can say that we can describe salt as something that is soluble in water. What that means is that salt will dissolve in water. Now, what does that actually mean? The term dissolve could be a little bit tricky because I guess you could use the term dissolve when you talk about an acid dissolving like metal, for instance. But in that case, the term dissolve means something different. In that case, when an acid's dissolving a metal, it's actually a chemical reaction. You are actually changing the particle. But when we're talking about solubility and the term dissolving in relation to solubility, what that means, what we're doing here in that case, is that we are taking a particle of, let's say, salt, let's say a crystal of salt, not a particle of salt, a crystal, let's say that, because we saw that the salt crystal looks like a cube. Now, if we were to zoom in into that salt crystal, you would see salt particles. I'm going to draw them as maybe like little circles, for example, okay? So imagine that my salt crystal is made up of like salt particles that form a cube, maybe something like this, okay? So that if I was to zoom in, what I would just simply see are a bunch of salt particles that are stuck together like that. that actually give the salt its cube structure, okay? So when something dissolves in terms of solubility, what actually happens is that the cube breaks down. If you ever put like a sugar cube in water, it does the same thing. And these particles actually get released. Now, nothing happens to the particle. The particle is still the salt particle, doesn't change. What we're changing is the structure of the crystal, okay? So if something dissolves in water, then we consider it to be soluble. And if something doesn't dissolve in water, then it's insoluble in water, okay? So solubility, again, it's just another way of describing matter. Like, for example, starch, there's, fiber. So, for example, fiber is insoluble in water. So if you put fiber in water, it doesn't dissolve. Nothing happens to it. It just sinks to the bottom or floats to the top. Nothing happens to it. Okay. So that's another way of describing matter. The next term is viscosity. This is a description of matter in terms of how well it flows. So when you pour it, for instance, which I have a picture of. So if I take example here, it looks like I have water. It looks like this is oil, and this looks like it's maybe like molasses, like a corn syrup. Okay, something like that. The viscosity is the rate at which it's a measurement of how quickly something flows. So it's actually the way you define it is its resistance to flow. So if something has high viscosity, that means it flows very slowly. So if I compare, for instance, this beaker, you see the water is at about there, whereas the oil is at about there, whereas the molasses or corn syrup, I'm not really sure what this is about there. This tells you that there's a higher flow rate in the water and a very low flow rate in the corn syrup. So we would say then the corn syrup has high viscosity and the water has very low viscosity. Again, what that means is that the water will flow really quickly because it has low viscosity, whereas the molasses will flow very slowly. Okay, so that's just, again, another way of describing matter. Okay, so the next term is density. So this is actually something that we're going to look at next week. So next week, we're going to talk about density. We're going to focus on what this is. We'll do a whole bunch of calculations. There's a formula that we'll look at where density is defined as the mass over the volume. So you can see that's what the definition is. It's the amount of matter, which is another way of saying it's mass, over the volume. So the mass over the volume. We talked about this last time. For example, metals are very dense. If you remember, osmium has a density of like 20, I think it was like 22 grams per centimeter cubed. Whereas gases, if you remember, like oxygen or helium, their density was something like, I can't remember exactly, but it's like a very, very tiny number, like 0.0001 gram per centimeter cubed. So again, just another way of defining matter. Now, what that means, it's not the same as mass. Don't confuse the two terms. Like, for instance, 1,000 grams of a gas is the same as 1,000 grams of osmium. It's like, what's heavier, 1,000 kilograms of feathers or 1,000 kilograms of steel. They're both 1,000 kilograms. So what's the difference between 1,000 kilograms of feathers and 1,000 kilograms of steel? Obviously, the feathers would take up more space. That would be the difference, right? So mass is one thing, density is something different. Density is the amount of mass over the volume. And this is, again, something that we'll look at in detail next week. Okay. So I have a question. So why do we use these two units for density? Because that is the definition of density. Density is mass over volume. Okay, but again, we'll deal with that next week. Okay, and you can see the unit grams. It's a unit for mass, and this is a unit for volume. Okay, but again, we'll talk about that again more in detail next week. We can also describe matter in terms of how shiny it is. That's its luster. So, for example, metals tend to have high luster, or we can say they're lustrous because they're quite shiny often. That's another way to describe matter. We can also describe it whether or not it's magnetic. So if a magnet will stick to it, it means it's magnetic. Iron, for example, magnets will stick to iron. Magnets will not stick to copper. So copper is not magnetic, but iron is. If you remember the last time when we talked about the periodic table, we looked at metals. And one of the properties of metals is that they're conductive in terms of heat and electricity. What that means is that heat and electricity can easily flow through metals if it's conductive. Now that makes sense because, if I have, for example, a pot, usually my pots are made out of metal, right? Now, why metal? Because we want the heat to be able to go through the pot easily. And you'll notice that metals heat up really quickly. They also cool down really quickly because heat flows through metals very, very easily. But we also use metals for electricity. The example below was copper wiring because metals also allow electricity to flow through them very easily. That's why there's, if you look at your phone charger, you see, you don't see the metal, but if you take, because it's covered in some sort of a rubber or plastic coating, but if you take away the plastic coating, inside would be metal because we want electricity to flow through the wires very, very easily. Now, all of these things here, okay, these are all physical properties. These are all ways of describing matter without changing the particle. Nothing's going to happen to the particle, okay? The next set, though, are the chemical properties. Now, these are ways of describing matter when there's some sort of a chemical change. So that means that we're getting a new type of particle. So maybe I should explain the difference between the two. So previously, we did not create a new particle. So, physical properties, just a way of describing matter without really changing the particle of the matter, right? But chemical properties not like that at all. So let's actually talk about what is a chemical change versus a physical change. So a chemical change would be like if I take hydrogen and oxygen and I get water, okay? Or if you remember last time, we talked about the reverse of that, electrolysis, water to hydrogen and oxygen. In this case here, you're creating a new particle. The hydrogen particle, the oxygen particle, and the water particle, they're different, right? The water particle is different. It's a new particle that you are making when you have a chemical change. Whereas in a physical change, what I'm doing is I'm just taking the same particle. Maybe, for example, it's liquid water, and then I freeze it into ice, or maybe I boil it into steam, but the particle doesn't change. So in a physical change, the particle stays the same. Okay, nothing happens to the particle. But in a chemical change, we are getting a new particle, which you can see here. This is a new particle. There are ways to tell if you have a chemical change. Usually with a chemical change, you're going to see signs of a chemical change. Like, for example, you might see light forming. So there is an example below. So if I scroll down, this is a magnesium burning. So you can see that it's producing light. Another sign might be bubbling. This is actually like zinc type of metal and a type of acid that are undergoing a reaction, so a chemical change. And you can see bubbles. Okay. Or another one is heat. Now, truthfully, you would get heat also with the magnesium burning. This is actually sodium in water. And you could see that it looks like it's burning. So it will be giving off not only light, but it would also be giving off heat. So there are certain signs that indicate that you're getting a chemical change. So like light, heat, bubbling, those are all examples of signs. The other one will be color change. So if I mix, like, for example, like, and this should be actually unexpected. Should clarify that. Unexpected color change. So if I mix like a red and a white substance together and I get pink, that's you expect that, right? That's not a chemical change. That's just colors mixing. But if I mix a red and white substance together, and for instance, I get maybe I get like green or blue. Yeah, maybe I get blue. Now that's not expected. That would be probably a sign of a chemical change having occurred. Okay, but in any case, so that's the difference between a chemical and physical change. So a chemical property is a way of describing matter in terms of when it reacts with something. So when you have a chemical change. So typically the three ones that you'll see is whether or not the matter is combustible, whether it reacts with an acid, or whether it reacts with water. Those are the three types of chemical properties that you can typically come across. If it's combustible, that means is that it's actually reacting with oxygen. So in the example with magnesium here, you can see the magnesium is burning. This is actually a reaction between magnesium and oxygen, forming a new particle called magnesium oxide, a totally new particle, okay? Or you could talk about whether or not it reacts with an acid. So that would be the example we showed with the bubbling. So that would be, for example, this one. So here is, a metal reacting with acid. Now, some metals do, some metals don't. Like if I put copper and an acid, there's going to be no reaction. Some metals will react with acids, others won't. How do you know if they react? Well, because you will see bubbling. All right, that's a clear sign that there's some sort of a reaction occurring. And lastly is whether or not it reacts with water. And that is actually the last image. which is the example with sodium. This is sodium reacting with water. Okay, so what we did then is we reviewed the properties of matter, and then we started with a review of classification of matter, and now we looked at the properties of matter, and we talked about the two types: the chemical properties and the physical properties. Okay, so let me stop recording, and then I'll take any questions.